Cool. Hello, hello, hello. Right, guys, we are down to the last two transformation, and hopefully we'll finish it today. And they are stretch and shear. Okay, they are a little bit more complicated. Well, shear is. Stretch is not so bad. What is a stretch? That is a stretch. Check out this. Okay, take this balloon, and I stretch it. That's what a stretch is. Okay, so we're stretching either in the y direction or in the x direction. Okay, obviously you can stretch it in a different direction, but we're not going to deal with that. Okay, whenever you stretch, and actually it's for shear as well, you have to think. I just want to make sure it's recording. Yeah, you have to think what direction will remain invariant. I don't know if I've ever used that word invariant. Invariant means it doesn't change. Okay, so if you think about that, when I'm stretching in the y direction, which coordinate will remain the same, the x or the y?
The X.
The x. So the invariant direction, the invariant axis is the x, which is 90 degrees to the stretches in the y direction. The x direction remain, or x coordinates remain the same, invariant. If I'm stretching in the x direction, obviously the y-axis now is invariant. Okay? So let's start with, that could be a y stretch. So we've got this triangle, this green triangle, and I'm stretching it, turning into that blue. Okay? Stretches it. The x coordinate remain the same. This coordinate become that, that become that, that become that. The x are the same, but the y increase. Okay? So our mission is to find the transformation. Okay, so let's say, let's just do it like that. How do we do it? Obviously, we need to look at our 1, 0, the unit vector, right, and the 0, 1. Okay, now we're gonna start with. I'm just gonna pause this for a second. Okay, right. So we are stretching in the y direction. And it's a bit confusing because we call it stretch invariant line x. So the x direction remains the same. I've also written here scale factor k. Okay, that means basically how much are we stretching it. Okay, so let's do it as normal. Okay, we're taking 1, 0. Let's use the same color. Okay, so we're gonna take the 1, 0. Okay? If we're stretching in the y direction, we say the invariant line is x, what will it be transformed to? Will it be transformed? No, it stayed the same, so it will be 1, 0. Okay? Invariant doesn't change. Okay? But the 0, 1 will be transformed. Okay? What will it be transformed to? Good question.
Depends how much you stretch it.
Exactly. So if we're stretching it by a factor of k, it will become 0k. Okay. All right. 0k. It will stretch. Okay. I can draw it. Let's draw it like that. It will become 0k. All right. So now we just got to write down the matrix. Okay. What will be the matrix? 1, 0, 0, okay. As simple as that. As simple as that, okay? Just pause here. Okay, so before we moving on to the stretch in the x direction, let's do a little example. Let's say we have that like a little stick, okay, between the line between 1, 1 and 2, 2. Let's find out what would this stretch invariant line x does to it. So 1, 0, 0. Okay, we need to decide on the k. Let's decide on the k. 3. Okay, and how we're gonna have to basically put each point on it. Okay, so we'll start with 1, 1. Let's see what it does to 1, 1. Okay, so 1, 0 times 1, 1 is equal to, how's your matrix multiplication these days? Is 1. Okay, 0, 3 times 1, 1, 3. Very good. Okay. So this point will become 1, 3, which is, let's say, here. Okay? Yeah. Now, 1003. Okay, I can tell you already in the exam I've put stuff like this, and you will get shapes. I can tell you, I'll give you a shape actually with like parallelograms or quadrilateral, and then you need to just on each coordinate put the matrix, find out what's the new coordinate, and find out what does the new quadrilate looks like. Okay, so here I just did a little line. Okay, in a test it will be more like this, and you need to see what happens to it. Okay, I'm just kind of, we don't have time now, so just the stick. Okay, so we're gonna put 2, 2 now. Okay, what are we gonna get first? 2, and the second row, the y will be 6. So 2, 6. This one is gonna be 2. 6 is like somewhere here, right? And what did I say? 3, 4, 5. Let's say 6. Okay? So you can see it's not just moving up, it's being stretched. It's getting longer in that direction. In the x direction, it doesn't change because it's invariant line. All right? Cool. Just pause here for a second. Okay, so there was a question here from Olivia who was thinking, okay, so I can see it stretching, but it's not just stretching, it's also moving. Okay? So looking at that balloon, for example, I can see, sir, you're saying it's stretching, but your thumb, my thumb, is not moving. Everything else on the balloon is stretching and moving up, but my thumb is not moving. Right? That's kind of what you're asking, okay? Where here, this is also moving. So the answer is, this is not my thumb. My thumb is here. Okay? This is actually a point on the balloon, and it will go up.
Okay.
So just to add that, we'll add another point. Let's add another point. Okay? This point is 1, 0. This is my thumb. Okay? Now, so we've got this thing. Looks like this. Now if I try to do this 1, 0, 0, 3 on 1, 0, what will I get? 1, 0. In other words, this stays in the same place.
Okay.
Okay? And now the new shape, I'll use a different color. Let's use red. There's 1 point here, 1 point, the second point. So this one moved to there, this one moved to there, but the first one stayed in the same place. That's why we call it, it's a very good question, that's why we call it an invariant line X. Anywhere on this X-axis will be invariant, it won't change. Okay? Cool. Now, I want you guys, I was kind of a bit out of frame. Sorry guys, let me just fix that. Okay, so yeah, sorry guys at home, I don't know if you saw this matrix, it was a bit out of the frame. This is a stretch scale factor K, where the invariant line lies on the x-axis. Anything on the x-axis doesn't change. It's 1, 0, 0, K is a scale factor. Now, what will be the matrix if now I'm stretching in the x direction, leaving the y-axis as the invariant line? Can we try and guess that? I'm going to let you think about that whilst I write. So, very good guess here from Larissa. All we got to do is just swap the k and the 1. Okay? Now, let's just, as normal, show that it does work. Okay? So, in the usual way, okay? The 1, 0 now, that is going to be stretching, isn't it? The stretch is in the x direction. Okay? So, the 1, 0 will be transformed into stretched by a factor of k, so k is 0. And the 0, 1 is invariant because it's on the y-axis, will remain 0, 1. And voila, we got k 0, 0, 1. Okay, pretty easy, eh? Great, I'll pause here. Okay, just one more thing actually for stretch. Okay, it's a tiny little point. I never really saw it in a question, but it's in the book. So when I'm stretching these shapes, okay, if I take 2 lines, okay, the line, a line before the transformation and a line after transformation, they should cross in the origin. Okay, you can kind of see it, isn't it? But it's just a tiny little fact. So I'll pause, I'll stop here, and we'll do a new video for share.